going to start with the third part of our assignment where we have to use cursor to generate neural network code for MNIST classifier using Keras along with the supporting metrics, and this is the walkthrough for that. And the first thing I did was like installing cursor from here, and then I have it here, and then we are going to be using that for on the MNIST library, which is nothing but Modifier National Institute of Standards and Technology. So this is basically like the I would say it's like the hello world of this. Um, yeah, it is like a subset of a larger data set, and the modified part of it comes from pre-processing the data set to make it more useful for machine learning. And it is one of the most well-known data sets in machine learning and deep learning, and it has like a collection of handwritten digits from 0 to 9, and it's used highly for training and testing in the computer network, computer vision or the neural network. So the first thing is I downloaded cursor and I gave it that we have to give it few prompts that what is to be done in this particular project. So the first thing is generate a neural network classifier for the MNIST dataset using Keras, and then I gave the next comment as include all the necessary pre-processing, architecture, training, evaluation, and visualization. And I also gave a few metrics, like few graphs to be plotted, like the confusion metrics, classification report, and also the accuracy or loss plots. So right after I gave this, it started generating code. So as you can see, all the imports are done, and then it took all of the metrics, whatever we needed, data sets, models, everything is done. And then we have TensorFlow, Keras, NumPy, Matplotlib, everything. And then here we're taking the data set, so you can see training and testing with taking it from the MNIST data set. And then the second thing after that is it told me to normalize the pixel values and it generated code for that. And then it converted all the labels to one hot encoded vectors. And then even for the model, it automatically gave me a sequential model and added three layers to it: flatten, dense, and you can see the input shape and then the activation parameters for both of them. And then the next part is like the compilation, which is nothing but we use the Adam optimizer for this based on the accuracy, and then train the model on the training data, and I gave Firefox, oh sorry, the code generated Firefox, and after that it started generating like the model and then how to make the prediction. And then this is the confusion metrics that is there, and also this is the classification report. And then this is for storing the history, it gave me a few other things, and this is the confusion metrics plotting. This is the plotting of accuracy and loss, and this is the last history loss. And then I got a few errors, so it was telling me how to fix them. So as you can see, when I tried uh, so when I tried executing the code, I was getting a few errors. So using the chat box, I was giving it a few of these errors and I asked it to fix them, and then it gave me suggested code, and then I replaced that and I checked and it was working fine. And then I also asked it to remove your variables, and then I don't want to use history, and then it gave me alternative code for that. And then I also gave it a prompt saying give me some test data so that I can check the accuracy and like check the predictions. So it also gave me that, and then gave me two options of like if I want to take one sample and if I want to take multiple samples. I use the second multiple samples one. Now let's go to the code. So this is what I have. I directly pasted everything directly from the cursor to my collab, and then I just divided the code into two because if there are errors then I don't have to like run the whole cell again. So this is the first part of the code where we're loading the data set, normalizing it, building the model, compiling, training, and evaluating the model. As you can see, we got an accuracy of 97%, which is good. And then this is for the prediction part. And then this is where I'm plotting a few graphs. So again, like this is the confusion matrix. Then this is the accuracy and the loss graph, and you can see the train and the validation. And then this is the prediction part where I've taken 5 samples randomly and then I tested on that. So you can see the prediction is 7 for the first one, 2, 1, 0, and 4, which is very accurate because everything is predicted correctly. So yeah, that is about it. And yeah, so this was very easy to use, and I think for even for assignments, I think we can do the same thing where we have to like use any of these. And then I almost got an accuracy of 98% with basic architecture. And then if we want better performance, like if you want more accuracy, I think we can also mention that we'll have to use convolutional neural networks or fine tuning the hyperparameters like the learning rate, batch size, like adding dropout layers and all of that. So yeah, that is about using cursor and getting a model done from it. Thank you.